Geometry, Unit 14, Section 2, Secant Segment Lengths. So given this image here, we want to explain why triangle ACD, let me highlight a little bit here. So triangle ACD goes from A to C to D and back to A. So why is that triangle similar to triangle ECB? So E also to C and to B and then back. So these two triangles here, I lost a little bit on that one. Why are these two triangles similar? Now they may be congruent, but I'm not concerned about the congruent. They kind of look congruent to me, but actually no, they don't. Now that I think about this, so this one looks a little bit smaller. But why are they similar? And we want to prove this through angle. Remember, for congruency, that means that all three pairs of corresponding sides are congruent, and all three pairs of congruent corresponding angles are congruent. But for similarity, the triangles aren't the same size. They are the same shape, but not the same size. So that means that the corresponding angles must be congruent, but the corresponding sides are not. They are proportionate, not congruent. They can be, but they have to be proportionate, but they don't have to be congruent. Remember, like if something's congruent, it is similar, but if something's similar, it's not necessarily congruent. Kind of like how a square is a rhombus, but a rhombus doesn't have to be a square. So let's see here. Why AA? Why not AAA? I said all three pairs of corresponding angles must be congruent. Well, it's enough to prove two, because if you have two pairs of corresponding angles congruent, then the third has to be what the third is, because the three of them adds 180. Like if my two angles are, you know, um, 80 and 40, for a total of 120, and my other two triangle house also has 80 and 40 for a total of 120. Well, then that third angle in both those triangles has to be 60. But anyway, so angle is enough to prove similarity. And the first thing we see here is we have angle C in both triangles, and we see that also when they're written, that angle C is a reflexive angle in both triangles. And then the other angle that's maybe not as obvious is angle A and angle E are congruent. So let me write this down. Angle C is congruent to angle C. And then also angle A is congruent to angle E. Now, why is angle A congruent to angle E? Well, angle A is an inscribed angle. Its vertex is on the circle. And inscribed angles are half of the arc inside of it. And angle E is also an inscribed angle, half of the arc. So since A is half of arc BD and E is also half of arc BD, then regardless of what arc BD is, those two angles are going to be congruent in measure. So that proves it right there. These two triangles are indeed similar. So then true or false? AC over EC. And so AC over EC. So those are two pairs of corresponding sides. Would their ratio be equivalent to CD over CB? Well, let's see. If we were to think about it like this, this is the longest side of the yellow triangle over the longest side of the green triangle, and then CD is the shortest side of the yellow triangle, and BC is the shortest side of the green triangle. So yes, they would be proportionate. So that does work out. So this is a true statement. Then how about this? You think the length of AC times the length of CB equals the length of EC times the length of CD? What do you think about that? That times that type of thing. And the answer is yes, that is true, because this is what comes from the cross multiplication of the proportion right here, that AC times CB equals EC times CD. Now, what's the purpose of this? Why am I starting a video talking about this? Because what we just said here, AC, that's this whole length of, that's called a secant, because it hits the circle in two spots and it's got an interior part and exterior part. Secant AC times BC. So this whole thing times its exterior part equals EC, this whole secant's length, times CD, its exterior part. And that is really the most important thing about talking about the lengths of secants. That when two secants intersect at an exterior of a circle, so these are two different secants and they're meeting here, the product of the exterior segment and the whole exterior segment of one secant. Let me say this again. The product of the exterior segment and the whole exterior segment of one secant, I think I still read it wrong, is equal to the product of the exterior segment and the whole segment of the other secant. Basically, this whole length, which if this is A and this is B, is A plus B, times its outside piece, its exterior part, is equal to the product of this whole piece, which is C plus D, times its exterior part. And a lot of times you'll hear me say in class like whole times outside equals whole times outside, or whole times exterior equals whole times exterior. And so we get this times this equals this times this, and of course if we're missing one of those things, we could do a little math to find out what that is. Now if it's a secant and a tangent, it works out that it's still the whole times the outside, so the whole thing A plus B times the outside. But for a tangent, there is no interior part. The whole is the outside, so it's times the tangent squared. So the whole times outside, exterior times whole equals tangent squared. And why is this the same? Because the exterior is the whole for a tangent. So it still is kind of like exterior times whole, but for a tangent, that's just C times C. It is the exterior is C and the whole thing is C. So that is still kind of like whole times outside. All right, so these are really, that's what you have to remember about the lengths of secants. The whole times outside equals the whole times outside. Outside and exterior is, same thing. So a couple quick practice problems here. LC, the whole secant. Let me draw a better bracket there. The whole thing, ALC, is 9. And its outside piece is 6. Well, the whole thing of LB is 18. What is its outside segment? LE, excuse me. So, I mean, you could have your calculator to do some of the math for you, but what this is going to be whole times outside, so that's 9 times 6 equals the whole 18 times the outside is 18 times x. Whole times outside, 9 times 6, 18 times x. And, 9 times 6 is 54 equals 18x divide 18, and x equals 54 divided by 18, right? Oh, get rid of that. So 9 times 6 is where the 54 came from, divided by 18, and we get 3. So x equals 3, which really means LE equals 3. Remember, unless it says find x, your final answer should never be x equals. You're just using x as a tool to find that piece there. Let's try another. HT, this interior part of a secant is 5. TA, its exterior is 4. Find MA, which is a tangent. Now, this is not going to be 5 times 4. Because remember, it's the whole thing times the outside. And so the whole thing must be 9 because a whole is the sum of its parts. So that's really the whole times the outside here is 9 times 4 equals the whole times the outside for a tangent is the same thing, x times x, x squared. So whole times outside equals tangent squared. Whole times outside equals whole times outside, same thing. So 36 is x squared and x equals 6, so MA equals 6. One more. BC is 27. AE, this whole thing is 20. BC is 27. AE is 20. This is clearly not drawn to scale. That's okay. DE is 12. Find the length of AC. So this one's a little harder because we're missing a lot. Like for this secant AC, the whole times the outside, I don't have the whole thing, and I also don't have the outside. So I'm going to need to create an expression for this. The whole thing, the expression is x. The outside piece is going to be x minus 27. Because you can get a part by doing the whole minus one part gets you the other part. right? I mean, if we look at this up here, that, 9 minus 4 was 5, and 9 minus 5 is 4, right? The whole times a piece is the other piece. So this is going to be my whole times outside here, x times x minus 27. And then whole times outside over here is 20 times, again, I don't have something here, but this is a little bit easier because 20 minus 12 is 6. So that would be 20 times 6. And this is going to be a little bit of algebra here because this is going to be x squared minus 27x equals 20 times 6, 120. And at this point, you can't solve for x when you have an x squared and an x to the first. See, here we had an x squared, and we just did square root of both sides. That's not going to work if you also have an x to the first in there. So when you see that happen, you need to set it equal to 0 to one side. So I got to subtract 120 over and factor. And so I'm thinking about numbers that multiply to negative 120. And you can guess and check a little bit, but a nice little calculator trick I'll show you real quick is if you go to y equals and type in negative 120, the number you need the factors of, and divide it by x. So negative 120 divided by x, and then take a look at your table, second graph. These are all the numbers that multiply to negative 120. So now I'm looking at this list for a pair that adds to negative 27. So let's see, negative 27. This one gives us negative 26, which makes me think there might actually be a mistake here, unless I made a mistake, which is very possible. I mean, we got 20 times 6 is 120. I didn't mess anything up there. Let me check, make sure I didn't put something in the wrong spot. This is where it'd be nice if you were in class, you tell me what I did wrong. BC is 27. AE is 20. DE is 12. Oh, here it is. This isn't 6. This is 8. Sorry about that. So this is 20 times 8. 20 times 8. That's a little different. That's 160. All right, so 160. Sorry about that. So we go y equals, and let me type in negative 160 divided by x and try that. See if we can find something that combines to be negative 27. Let's see if we take 5 away from negative 32. That will do it. So that's it right there. This combines to be negative 27, 5 and negative 32. So that means my factors are x minus 32 and x plus 5. One at a time, they're set equal to 0, and you get x equals 32 when you solve, and x equals negative 5. And the negative 5 is going to get rejected here, just because this whole length can't be negative. Now, negatives don't always get rejected, but in this case it will. So x here is 32, which means AC equals 32. All right, sorry about that error. That cost a couple of minutes, and we'll practice more of this in class.